Hello class 10. We will talk about metallurgy today. Okay. But again, before we start the metallurgy, we have to know the differences or the properties of metals and non-metals. But before I continue, I just want to tell you what metallurgy is. It's a totally new chapter for you all. So metallurgy is a large-scale process involved in the extraction of pure metals from their respective ores. Okay, so metallurgy is a process, a large-scale process which is used in the extraction of metals from the ore. So we extract metals from the ore. This process is called, the entire process that we study is called metallurgy. So before we talk about the extraction of metals and metallurgy, we are going to compare the properties of metals and non-metals. Okay, so what is a metal? So metal is an element which ionizes by the loss of electrons. Okay, so an element which ionizes by the loss of electrons, or it loses one or more electrons when supplied with energy and thus forms positive ions. This is called a metal. What is a non-metal? A non-metal is an element which ionizes by electron gain. It gains electrons and forms negative ions, or they are electron acceptors. So those elements which are electron acceptors are called, and forms negative ions, are called non-metals, whereas those elements which are electron donors and forms positive ions or cations are known as metals. So metallic atoms, as you know, those elements which are metals will always have, we already know that it has in the outermost shell or the valence shell, it has 1 or 2 or 3 electrons. Yeah, and it forms cations or positive ions on ionization, and they form electrovalent compounds. And they form what? Electrovalent compounds. Electrovalent compounds are those compounds which are formed by the transfer of electrons. Now when we come to the non-metals, the non-metallic atoms will have 4 or 5 or 6 or 7 valence electrons in the last shell, and they tend to form negative ions or anions on ionization. How? By the gain of electrons, and they form electrovalent or covalent compounds. So non-metals, when it combines with metals, they form electrovalent compounds. When non-metals and non-metals, they combine to form compounds, then they form covalent compounds by the sharing of electrons. Now valency, we know that they form ions by the loss of electrons. So valency of a metal is the number of electrons excuse me. Valency of a metal is the number of electrons lost per atom. That is, it forms negative ions. It may be monovalent, divalent or trivalent. It forms positive ions. Just remember that, by the loss of electrons. Whereas non-metals, they are also univalent or divalent or trivalent, formed by the gain of electrons. They form ions by the gain of electrons. So those elements, those metals which loses 1 electron to form a stable electronic configuration during formation of electrovalent compounds, those metals which loses 1 electron is called univalent. That means 1 electron is being lost, so it is valency is 1, univalent. It loses 2 electrons, like magnesium. It loses 2 electrons during the formation of electrovalent compound, then the valency of that metal is 2. If it loses 3, in the case of aluminium, if it loses 3 electrons, then it is trivalent. Similarly, non-metals, if it gains 1 electron, it is monovalent, like chlorine, fluorine, iodine, bromine. If it gains 2 electrons, in the case of oxygen, sulfur, it gains 2 electrons, so therefore it is divalent. And nitrogen will have 3 electrons, needs 3 electrons to have a stable electronic configuration, therefore it forms, therefore it is trivalent, so it gains 3 electrons, so therefore it is trivalent. So this is all about valency. Now we come to properties of metals. Properties of metals and properties of non-metals we have learned, we know since class 6. So anyway, we'll quickly revise it. Metals are lustrous, means they have smooth and shiny surface. They can be polished, right? And they exist in a solid state, except for mercury. Whereas non-metals, they are non-lustrous, except graphite. Graphite is a non-metal or an allotrope of carbon. Graphite, pencil lead as we call it. So it is lustrous. And iodine, of course, it has a shiny surface, iodine. So graphite and iodine, they have a lustrous surface, but rest of the non-metals, they are non-lustrous, and they exist in liquids, usually in liquids and gaseous states, as well as solid. Even if they are in the form of solid, they are brittle. Okay. The only liquid which is a non-metal, as we all know, is bromine. Now we come to the melting and boiling point. It will have high, usually metals have very high melting and boiling points, except for sodium, potassium and mercury. They have low melting points. When we talk about the melting points of non-metals, they have a low melting point, except for carbon and silicon. Density, the density of most of the metals are very, very high, except for sodium, potassium and calcium. The top 3 reactive metals, potassium, sodium and calcium. The density is low. Usually the density of metals are very high. Now we come to the density of non-metals, and you know that density of non-metals, they are low, except for diamond. It's the hardest substance known to man. Non-metals are supposed to have a very low density, but again, the highest density or the hardest substance known to man is a diamond. It is diamond, which is an allotrope of carbon, a non-metal. Ductility means, what do you mean by ductility? The property of a substance which can be drawn into wires are called ductility. Most of the metals are ductile. They can be drawn into wires, except for mercury and zinc. Okay, zinc is a very, very brittle metal, so it cannot be drawn into wires. Non-metals, most of the non-metals, almost all the non-metals are non-ductile, except for carbon. Carbon we have because we have carbon fibers. Malleability. Now, when we talk about malleability, is the property of an element which can be a property of a substance which can be beaten into sheets. This is called, they are malleable. Okay, so metals are usually malleable, but except for again zinc and mercury, they cannot be beaten into sheets. Whereas most of the non-metals are not malleable. They are non-malleable. Conductivity. Metals, usually all the metals are good conductors of electricity as well as heat. Okay, over here again, when we talk about the non-metals, most of the non-metals are bad conductors of heat as well as electricity, except for carbon, because carbon in the sense graphite, okay, an allotrope of carbon, which is a good conductor of electricity. Now, when we talk about reducing agent, metals are good reducing agents, whereas non-metals are oxidizing agents. It's a bad reducing agent, but a good oxidizing agent. Okay. So these are the different properties, or the comparison of properties of metals and non-metals. So now we will continue with some of the terms that is used during used in this chapter called metallurgy. Okay. Now the occurrence of metals in nature. Now we know that metals are not found in a pure state. Metals are reactive, so therefore they combine with other substances, and they are found in the Earth's crust in the form of minerals. Okay, they are not found in a pure form, except for gold and platinum, or maybe silver and copper. These metals, gold, less reactive metals like gold, silver, platinum, copper, they are found almost in a free state in the Earth's crust. But the rest of the metals, they are reactive, so they are found in the Earth's crust in the form of minerals, and we have to extract these the metals from these minerals or the ores. And this process, the entire process, is called the metallurgy. So occurrence of metals we will discuss. Free or a native state, number one. Metals occurring in a free state or free metallic form, not acted upon by the natural elements like constituents of air and water. They are gold and platinum. So gold and platinum are found almost in a free state in the Earth's crust, whereas the other metals, they are found in a combined state. Metals occurring in the form of compounds like oxides, bauxite, zincite, hematite, cuprite, carbonates, marble, calamine, magnesite, halides, cryolite, fluorspar. We discussed this cryolite and fluorspar. We'll discuss about it. We have already discussed actually, or we will discuss it in the next part of the same chapter. Next is sulfides like iron pyrite, zinc blende, glena and all that. And sulfates, gypsum, andesite, barite, Epsom salt and so on. These are some of the minerals which from where we can extract various metals. So minerals and ore. Now what is a term mineral? When we talk about the term mineral, mineral is a compound. It's very, very important for you to understand. Mineral is a compound of various metals found in the nature associated with the earthly impurities. These are called minerals. So compounds of various metals which are mixed in nature with other earthly impurities, the entire thing is called the minerals. And from the minerals, we take out the unwanted substances and we take only those compounds which contains the metal. That is called the ore. So the ore is a naturally occurring mineral from which metals can be extracted profitably and conveniently. These are called ores. So there is a difference between the ore and minerals. Ore is the compound from where we can extract metals easily and profitably. That is called ore. And the ore mixed with earthly impurities is known as minerals. Please get the difference between mineral and ore. The other terms, I told you, metallurgy. Metallurgy is a large-scale process involved in the extraction of metals, pure metals, from their respective ores. Isn't it? Now we talk about matrix. Now what is matrix? The rocky impurities, including silica, mud, etc., associated with the ore is known as matrix. And what is a flux? The substance added to the ore. The substance which is added to the ore to get rid of the matrix, the unwanted substances. The substances added to the ore to get rid of the matrix or the unwanted substances, resulting in the formation of fusible compound, which is known as slag, is called flux. So if you want to go through the definition, it is on page number 130 in your textbook. Now we have discussed some of the ores here. Now we talk about the different ways in which we can extract metals. There are various steps involved in the extraction of metal. The first step is dressing of the ore. We get the ore, fine. We get the minerals, fine. Now we have to separate the unwanted substances, earthly impurities from this ore, and this is known as dressing of the ore. This is known as what? Dressing of the ore. The concentration of the ore or the separation of ore from the earthly impurities is called the dressing of the ore. And there are many ways in which we can, methods used in the dressing of the ore. So we'll discuss it later. Step 1 is dressing of the ore. Number 1, first we have to, like when we prepare pulao or when we cook rice, we wash it, isn't it? We wash it, we take out if there are stones or husk or other impurities from the rice, we take it out, we hand pick it. That means we are separating the unwanted substances from the rice. Similarly, here the dressing of the ore is somewhat like that. We wash it or do something in which the earthly impurities are removed from the ore and we get a clean, pure ore from where we can extract metals. This process is called dressing of the ore, step number 1. Now step number 2 is conversion of ore into oxide. Remember that step number 2 is also very important here. The concentration of the ore means, we suppose if the ore is in the form of oxide, suppose the ore is in the form of oxide, well and good, very good, well and good, we keep it. But if the ore is not in the form of oxide, like it's a form of the silicate, it is in the form of sulfide, if it is in the form of halides, if it is in the form of carbonates, we change it, we convert it into oxide. Okay? Like iron carbonate, we convert it into iron oxide. And this process is known as conversion of concentrated ore to its oxide. Why do we change it into oxide? Because it is easier to remove oxygen from, it is easier to get iron from iron oxide rather than iron carbonate. So it is easier to reduce. Taking away of oxygen, the loss of oxygen is called reduction. So it is easy to reduce iron oxide and form iron and get iron rather than try to get iron from iron carbonate. So we change conversion of concentrated ore to oxide means we have to convert the pure concentrated ore to its oxide, since oxides are easy to reduce. Step number 3, reduction of metallic oxide to its metal. So now we use different ways in which oxides of the ore, oxides that we got after the concentration of the ore to oxide, that oxide we have to reduce it. There are many ways in which we can reduce and to extract metals, to get pure metal. And then the last one is refining. So after we get the metal, we make sure that we get the purest form of the metal, and this process is known as electro-refining of impure metal. So these are some of the processes which are involved in the extraction of metals in metallurgy. In the next class, we are going to discuss the steps number 1, 2, 3, and 4 in detail. Okay? I hope you have understood whatever we have discussed so far. So see you in the next class. Thank you.